Welcome back to our lesson. We are now just looking at application questions to help us understand the concept that we have learned in the topic of compound proportions and rates of doing work. In our first part, we did look at 3 examples to help us understand what we've been learning. Now we're going to the 4th example. Now the 4th example, and as you have been seeing with the example we're dealing with today, they all have some kind of a twist. And this one is no different. So look at example 4. 3 pipes, P, Q, and R, each running alone, can fill an empty tank in 3 hours, 6 hours, and 5 hours respectively. Very important, the word respectively. So pipes P and Q are open at the same time and left running for 1.5 hours. Pipe P and Q are then closed and R is open and left running until the tank is full. How much longer does the pipe R take to fill the tank? How much time will R now take to fill the tank? We know that these first 2 were running for 1.5 hours. Now, pipe P can fill in 1 hour. Pipe P can fill a third of the tank, while Q in an hour, because of the time given, can fill a 1/6. So pipe P and Q in an hour can fill a third plus a 1/6, and that will be 3/6. 3/6 or a half. So what about in 1.5 hours? What about in 1.5 hours? It will be the same as 3/2 multiplied by 3/6. 3/2 multiplied by 3/6. So by 3 years 1, by 3 years 2. That gives us 3/4. So when pipes P and Q are left running for 1.5 hours, for 1 hour they'll fill 3/6 of the tank, which is a half. For 1.5 hours, they multiply that and then you get to be 3/4 of the tank that will be filled. So how much space is left? If 3/4 are filled, how much space is left? It should be a quarter. Now this quarter is filled by pipe R, and pipe R, from the information that we were given earlier, will fill a 1/5 of the tank in an hour, because it takes 5 hours to fill the tank. So in an hour it should be a 1/5. So how much time will be left, will be required to fill a quarter of the tank? So what we do here, to get the time remaining, we take the space remaining, divide by how much space is filled in an hour by the pipe R. So it will be a quarter times 5/1. That will be 5/4, which is the same as 1.25 hours. 1.25 hours, or 1 hour and 15 minutes to fill the remaining bit. So again here you have to need to go step by step, almost like in the unitary way. Just go from this step, how much is taken, how much is remaining, then how much will the other take to fill the remaining space. Step by step, and you get to your answer. Let's look at example 5. Now when it comes to working, we remembered from our last lesson we can deal with unitary method or ratio method, and it still works. 20 men can dig a trench 300 meters long in 15 days. Find the number of days it will take 30 men to dig a trench 360 meters long. We'll answer this by using both the unitary method as well as the ratio method. Let's first start with the unitary method. 20 men can dig this trench, which is 300 meters long, in 15 days. 15 days. Find the number of days it will take 30 men to dig a trench 300 meters long. 30 men, or 360 meters long. Find the number of days it will take. Now, if we were to take this as a unitary workout, let's put this one to be D. D. 20 men can dig a trench 300 meters long in 15 days. That will mean that the 20 men will dig a trench that is how many meters long in one day? 300 divided by 15, and that will be 20. So 20 men will dig 20 meters long. What about one man? One man will require this by that, and that will give you 400 meters long to do this entire work, okay, for that whole time. Now, rather than working it out like that, let's go ahead and work it out very simply so that we can finish it up. We're looking for the number of days. So the number of days should be 15 multiplied by. Okay, we have 20 men, they dig 300 meters. They take, 15 days. If we increase the number to 30, we increase the number of people, that means they will take less days. So we multiply by a proper fraction, it will be 20 over 30. At the same time, 300 meters is work done in 15 days. What about 360 meters? That is more length, more distance. It should take more days. So multiply by 360 over 300. Because it should take more days, because it's more work to be done. Then you work that one out. This and this cancel out. This and this cancel out. By 15 is 1. By 15 is 2. By 3 is 1. By 3 is 12. By 2 is 1. By 2 is 1. So how many days will you take them? You take 12 days to do this work. Now 12 days it will be 30 men, more men, and they'll do slightly more work, but they take less days because there was quite more. 10 more people can do that work, can do more work in less days. Now let's look at this final example here. We also talk about proportion, compound proportion. It comes to mix. Compound proportion means you're mixing up, let's say, mass as well as money. Mweni bought maize at 60 shillings per kilogram and beans at 150 shillings per kilogram. She mixed them in a ratio so that the mixture was worth 100 shillings per kilogram. That should be the cost price. But of course, when selling, she probably sells it at more than 100 shillings per kilogram to make profit. So find the ratio she used to mix the beans. So again, the ratio here could be x, and the other one will be 1 minus x, because the total is supposed to be 1. So Mweni 60 multiplied by x plus 150 multiplied by 1 minus x should be equal to 100. All of this is over 1 because the total is 1, so no need to write that 1. 60x plus 150 minus 150x equals to 100. Let's bring like terms together. 60x minus 150x equals to, this goes to the other side, 100 minus 150. 60x minus 150x will give you minus 90x. 100 minus 150 will give you minus 50. Then we divide both sides by minus 90 by minus 90. Minus 90 minus 90 x will be equal to 5/9. And that means the other ratio for beans will be 1 minus x. So 1 minus x will be 4/9. So the ratio used to mix beans to maize, again this one is important, beans to maize. Beans was 4:9. So beans to maize will be 4:5. You start with beans first and then maize, not maize and then beans, as the question is asking. So the whole topic we've learned about proportion, proportional parts, mean and third proportionals, unitary method, ratio method, compound proportions, rates of work, and you've done so much. So this is your assignment. We're posting it also on the Google platform. We'll be answering questions 6, 10, 15, 18, and 21 of exercise 14.3 in your Form 3 book by KLB. You should be page 272 to page 273. Just 5 simple questions to help you to see whether you understood the entire concept in this particular topic. So see you next time for a new topic. See you then.